Sometimes shops need additional magazine capacity to complete a job. In this episode, we're going to be talking about how you can eliminate the number of rough boring bar tools in your magazine by utilizing the tornado mill function in a circle mill unit. Let's get started with today's Mazak Minute. Hi, I'm Zillich, part of the HEH technical team. In today's Mazak Minute, we're going to be covering circle mill. Let's get started. If you look at my screen, point machining we can do both circle mill and tornado mill. The tornado mill gives you the ability to do a helical interpolation in a point pattern figure in point machining. A normal circle mill, which we've had for a long time, that will feed down in the Z-axis and then interpolate in X and Y, having you to have multiple steps going down in Z. Tornado milling unit, though, came in, I think, about the Fusion 640 time frame. That gives us the ability to move above the hole in the Z-axis. We'll shift over in X and Y to our rough bore diameter that we want to machine, and then it will helically interpolate down. The use of the tornado mills reduces the number of twin boring bar tools in the magazine, allowing you to have more capacity in your programs. When you go to the point machining on your soft keys down below, you'll see in the lower left, you're going to see right here with the arrow, you got point machining, line machining, face machining, manual program. We're going to go ahead and select point machining. From there, you're going to see the categories that we have or the operations available. You always choose your last operation that you want to use. So if you were tapping, you would select tap, and that would give you a center drill tap. But in our case today, what we're going to do is we're going to go right to circle mill. This is going to avoid us having to machine a hole in the part prior to machining a bore. When you come to the unit description, you'll see that you'll have the unit name circle mill. And then by the balloon number 1, you'll see it says tornado. You'll put a 0 for circular milling or a 1 for tornado. Number 2 will be the diameter. That's going to be the diameter hole size that you want to machine. 3, the depth. That's going to give you the enter the depth of the hole. 4 is going to be a chamfer. You're going to enter the chamfer size at the top of the hole. Sometimes people might put a 10,000ths in there or so. Or 20 just to break the edge. 5 is going to be the bottom micro finish. So if you'll see a number 1 through 9. If I put 1 through 9 in there, it will interpolate the entire bottom surface at the same Z value. 1 is going to be like your coarsest finish. That'll be like 1,000 micro. You keep on dividing them in half going to the right. So you have 500, 250. A 4 is going to be like a 125, 6 is going to be like a 63 micro finish. When you get to prepared diameter, this is going to be the prepared hole size prior to machining. So if you had an existing hole in there, you would put that size. But if you are going into just a piece of stock with no hole, you'll put a 0 there. Chamfer, you'll enter the chamfer size at the top of the pre-diameter hole. I'll use this if I'm doing the circle mill operation. If I do tornado, I'll come back with another operation with the chamfer. In tornado, the sharp end mill or the flat end mill will try and interpolate helically the chamfer. So if you go to your help screen, you'll see that on our easy controls, you'll hit the far right soft key and you'll hit the help soft key, or if you're on a smooth G or a smooth AI control, you'll go ahead and the question mark up at the top of the screen will bring up the help menu. Just a part of some of those questions that I would just refer to, you'll see that the diameter here is going to be the diameter of the hole, chamfer at the top, the depth. If I did give it a pre-diameter, you'll see that it will give me a chamfer at the bottom as well. The first one we're going to review is going to be the circle mill unit. Now we're looking at the sequence data. The sequence data is where you give it what tool you want to use. It will pull down some of the information from the previous data we put in, and then it gives me the ability to go clockwise or counterclockwise. And I will also, the depth will be my step over, and cutting speeds. Cutting speed will be in surface feet, and the feed rate will be inches per revolution. Don't get that confused with inches per tooth, but it is inches per revolution. Just to look at a quick review of the topic numbers, one is going to be the nominal size of the end mill. Keep in mind that the nominal size, if you're in inch, will be 2 places to the right of the decimal. In metric, it will be 1 place. Number is going to be used for priority number. Typically, I'll prioritize the program once I have the entire program completed. That gives me the ability, if I had several center drills being used for different operations, I can combine them all into one priority number to reduce the number of tool changes. Hole diameter, that's going to be the size of the hole. That information will come down from the previous selection that we answered from the unit description. For the hole depth, the prepared hole diameter, the pre-depth is going to be the cutting direction. You're going to see that there will be 2 soft keys, one listed as clockwise cut and the other one counterclockwise cut. 7 will be my roughness. Like I said earlier, if you look at the top up here in the screen, you'll see the roughness by 7 there. I have a 4. That's going to be like a 125 micro. Again, from the 1 being the roughest finish to 9 being the smoothest. The depth, number 8, is going to be the width of cut. That will be the radial cut. 9, cutting speed. In inch, that will be surface feet. In metric, that would be surface meters. Number 10, feed rate. That will be inches per rev in inch mode, or metric, millimeters per rev. And then the last one on the end there, number 11, you'll have 3 different M-code inputs. A lot of times you'll put your coolant on there. Sometimes I see people wanting to put an op stop there, but just remember that these M codes are activated prior to the operation cycle. Now we're going to go ahead and look at the difference between tornado milling. You're going to see that the unit description is slightly different. When you come to the number 1, you're going to see, like I said earlier, 0 is circular, 1 is tornado. So this time you'll see right here in our tornado we have a 1. We enter the diameter of the hole to be machined. The depth is going to be the depth of the hole. Chamfer, enter the chamfer size at the top of the hole. That is specified in item 2. And earlier I said that typically I'll put a 0 here because I don't want the flat end mill to interpolate the chamfer. 5 is going to be a bottom. And again, if I enter 1 through 9, it will mill the entire bottom surface flat. So if you're doing a, let's say, a counterbore for that you want the bolt head to seat flat, you would use definitely 1 through 9. But there's times where people want to, when they get to depth, they want to come right back to the arc center. Number 6 and number 7 are new ones here now. So you'll have pitch 1 and pitch 2. On the next screen, you're going to see that pitch 1 is going to be the Z-axis depth pitch of the chamfer, and pitch 2 will be the Z pitch for the hole. If I go to hit my help menu, again, the question mark at the top of the screen for the smooth G controls and the smooth AI, and for the EZ controls, you'll hit the far right arrow key, and then you'll see a help soft key. To the right here, you'll see the diameter, the chamfer, The chamfer again is going to be at the top, and you notice how you'll see that Z pitch one, and then the depth is going to be from the top surface down to the bottom, and the hole diameter size will be done at pitch 2. The sequence data for the milling unit, very similar to what we did with the circle mill. However, if you look at the pre-depth under cutting direction, one of the differences you'll see now is that the counterclockwise or clockwise will be in a highlighted pink magenta color. This is signifying that you're doing a tornado mill. I personally like to do counterclockwise. I'm a big fan of climb milling. All the rest of the fields are pretty much the same as what we did prior. Number 7 would be the depth of the chamfer, or the chamfer width. And what I'm going to do here now is I'm going to go ahead and we're going to go into a program that I've set up here already. And you'll see that you have your carbon steel, your initial Z 2 inches, ATC mode off, and multi-mode off. You can define your geometry of your stock. The WPC is going to be my workpiece coordinate, or my 0 point of my part from machine home. In Mazotrol programs now on the Smooth G and Smooth Easy control, we can now enter in a comment. So you'll see unit number 2 here. I have point machining circle mill. I'm going to come down here and hit program edit so that we can actually look at some of these fields. If I go to circle mill, I come over here to tornado, and you'll see how the number pad just keeps on moving based on where I click on the field. On this number pad, there is a pin that I can pin it so that that will not jump around on the screen. So tornado, if I come down here to look at my prompt box, you'll notice that the prompt will say 0 circular, 1 tornado. If I go to the diameter, it's going to ask you for the hole diameter. 2 is going to be the hole depth. Chamfer is going to be the width. And then you also have, and which I forgot to open up for you guys, I spoke to you during the PowerPoint presentation, is going to be the question mark. If I bring that question mark up, you're going to see that the unit description is still above us, and the 3D image is here, and you can see that this first chamfer is going to be the top chamfer. We go over to the micro finish of the bottom. Notice how it's in red, so I know that's the bottom finish of the counterbore. And then the pre-diameter, if there's an existing hole prior to machining, I would enter that in here now. Otherwise, make it a 0. And then finally, you put a chamfer 0 at the bottom. To remove the help image, I'm just going to go ahead and hit the question mark again, and that brings me back. The end mill, you can see across here, 1-inch end mill. If you have multiple 1-inch end mills, you can see you can have a what they call a tool suffix or a tool file code. You can go through letters A through Z. Numbers from the unit description, you can see the 1.5 came down from the top, the 2 inches, the pre-diameter, and the machines are, I think, already defaulted to probably go counterclockwise for the direction. Roughness 4. And the step over, if you look at number 4 here, or excuse me, the depth right here, notice it says the width of the cut. This is the radial amount of cut I can take. Speeds and feeds, surface feet, 20 thousandths per rev. So that 20 thousandths per rev is, this is a 4-flute end mill, that's going to be 5 thousandths per tooth. My figure pattern, I chose to put it as a point. Starting at the Z face is 0, and I put the circle mill operation to the left of the part, so you see minus 1.5, Y 0. I come over to the PQR, and if I click on the P and you look down in my prompt box, you'll notice that if I had multiple holes or multiple points, this letter P is going to dictate how do you want to move to the next hole? A 0 will move in the X and Y. A 1 will move the Y-axis first, then the X-axis. A 2 will move the X-axis and then the Y. You may use 1 and 2 if maybe you had a boss sticking up and you had to move one vector at a time, so either move the X and then the Y, or Y then the X. Otherwise, the path with a 0 will take the shortest path. If you go to the letter Q, you're going to have omit start point machining, yes or no. I'll use this when I have multiple lines and patterns, and maybe the 2 lines share the same start point. I don't need to machine the second series, that first start point hole for the second series, so I would eliminate it by putting a 1 in the omit start. And then finally, you got your R. That's going to be your return position. The return position can be a 0, which would be your initial. The initial is going to be, as you see at the top, we set that in our unit 0. That's the 2 inches up on top here. And then if I put a 1 in there, that goes to a parameter in the D parameters that is set, I believe, in the number of 10 thousandths. A lot of times you might see 100 or 120 set there. So what I'd like to do now is we're going to go ahead and do a tool path. So if I come here, I'm going to go to Program, Tool Path, and the first time I'm going to do it, I'm going to come down here and I'm going to go ahead and hit Part Shape on my soft keys. And Part Shape will give me both holes that I did. The one on the left is going to be my circle mill, and that's where you can see that I have that existing 1-inch hole prior to the hole, and then the outside purple circle is going to be the 1.5 inch diameter. If I go ahead and hit Pass Step, what you'll notice is that the tool comes down to the center of the hole. I'm hitting Pass Step, it's just like a single block. You'll see it comes down, cuts around, and does multiple passes. On the rough passes, you're seeing that it's feeding straight down in Y, but on the finish pass, it will actually arc into the cut, go a little past, and then arc back off to the center. If we look at the same view, and I go look at it now, I'm going to hit the orange icon on the right side of the display screen. That pulls up a side menu. If you're on an older machine control, what you'll need to do is go ahead and hit the right arrow soft key all the way on the right, and then you will get a plane change key. If I go to plane change, you're going to see I'm going to go to a XY, XZ view. And what that gives me now is it gives me the holes, both a top view and a front view. So if I come back in here, you're going to notice, remember I said earlier that in a circle mill, it's going to feed down in the Z-axis and then interpolate. Depending how you have your Endmill set up in your tool file, there's a maximum depth of cut. So as I go to run this, what you're going to see is we come to the center. This flute length, I did this on purpose, the flute can only cut so much. So what it will do now is it will go ahead and interpolate the hole at that first Z depth, and then it will come back to the center, feed down in Z, and go ahead and interpolate. On the graphics up here in the upper right, you see how it says coordinate? That is machine coordinate. If I hit the far right arrow key, you'll notice that there will be a soft key called position display. And now you're going to see that that position now references my workpiece coordinate. If we go back to review the, let's go back and review the tornado milling. So I'm going to go back to my program. I'm going to scroll down here to the tornado. And again, basically I'm using the same points. You'll notice that sometimes my surface feet might be able to go a little faster, which is going to give me, I'm still using the same chip load, but it's going to be going a little faster because of the RPM increase. We'll go look at the toolpath on that now. If I go to the toolpath, you'll see that my view is still set up as those two. And with the easy and the smooth controls, I can come over to my right arrow key, and there now is a path restart. What I'm going to do now is come over here to path restart. It's going to open up a window, and I'm going to go ahead and choose Unit 3, the second circle mill operation. I'm going to say OK. You can select which point. If I had multiple figure patterns, I could select which point I want to start at. And then I'm going to go ahead and hit the far right arrow key and come over here and do a path step. And what you'll notice now is that the tool on the right side hole, it comes to the center of the hole. You'll see that it's going to move over. It comes down to the R plane, which, like I said earlier, was probably 100 thousandths. If I look up here at my position, you do see that it is at Z.1. I do the path step, and notice how it moves over right to the diameter of the circle mill tornado diameter that I set. And now if you keep an eye on the bottom section here, this is the front view. As I hit step, you'll notice that I get a helical interpolation. At the bottom of that hole, what I can do is I can go ahead and it will finish mill because I put a number 1 through 9 in there, and now it comes back out. Now you may find that maybe your cut, you might say that I might be able to take a little bit deeper of a pitch cut. So I can go back to my program, and just for demonstration purposes, I'm going to go ahead and double it. I highly recommend that you get with your tool vendors. Certain end mills are rated for certain degrees of interpolation. Just find out what you can do. I'm going to go ahead and double it so we can see it on the graphic a little bit easier. I'm going to go back to program. And again, you notice I changed the pitch 2 here. Right there, I changed pitch 2. We're going to go to toolpath, part shape, path restart. Go ahead and do that second one. And now when I go to hit play, notice how I just increased that pitch 2. Quick and easy way to optimize your toolpath. And again, like I said in the beginning of our intro, this is a great way to eliminate the number of rough boring bar tools. Sometimes a lot of shops, they still have those older tools with the twin bores that they're trying to get a faster rough bore operation. With this helical interpolation, I can have one indexable end mill. Maybe in this case, I might have a 1-inch indexable end mill, and I can machine multiple different diameters, eliminating the need for multiple rough boring bar tools. Thanks for watching. We hope that by utilizing the tornado milling function, you're able to free up some space in your tool magazine. Leave your questions in the comments, and be sure to subscribe to our channel so you don't miss an episode. We'll see you next time on the Mazak Minute.